All right, welcome to the Explainer. Today, we're digging into a really fascinating strategic move from Microsoft in the world of multimodal AI. While it seems like everyone else is in a race to build the biggest, most massive models out there, Microsoft, well, they took a very different path with their Cosmos series. We're going to trace its evolution from a pretty general perception model to a specialist that learned this amazing little trick: how to point. So, let's kick things off with a fundamental problem in AI vision, one you've probably seen happen. A multimodal model looks at an image and just starts making stuff up, describing things that simply aren't there. We call it hallucinating. And it happens because the model's words aren't actually tied to what it's seeing. There's this disconnect. It isn't grounded in visual reality. Yeah, this is what researchers call the grounding problem. And it's a huge hurdle for multimodal large language models, or MLLMs. I mean, think about it. If you can't trust that a model's description actually matches the image, what's the point, right? Its entire reliability and accuracy just go right out the window. So after their first model, Cosmos 1, Microsoft's big answer to this challenge was Cosmos 2. And this is where things get really interesting. They designed a model that doesn't just see and describe something. No, it can actively connect its language to the visual world. In short, they literally taught it how to point. And the key innovation here is this idea of multimodal grounding. It's simple but brilliant. Instead of just saying, hey, there's a cat, the model is forced to prove it. It has to say, here's the cat, and it's right here at these specific coordinates. This little act of verification, it dramatically slashes the number of those pesky hallucinations. Exactly. So it's not just saying a snowman into the void. It's creating this concrete, verifiable link between the words a snowman and the actual pixels in the image that make up that snowman. It's literally pointing with its language, grounding every single description in visual context. Okay, now this is the real aha moment. The true genius here isn't just what they did, but how they did it. They didn't have to engineer some brand new complex system. Instead, they did something incredibly elegant. They just treated the coordinates for a bounding box as if they were just another part of the language the model speaks. And you can see it perfectly in the raw output here. The model generates a phrase like a snowman, and then boom, right alongside it, these special location tokens. Now, these aren't human words, of course. Things like patch_index0044 are basically just code for the coordinates that draw the box. But to the model, it's just another word in its vocabulary. So the whole workflow becomes incredibly transparent. You give it a prompt, and what you get back is this sentence that's interwoven with location data. Then, a simple post-processing step just reads those location words and draws the boxes on the image for us. It turns an abstract description into a concrete, verifiable output. But hold on, the evolution didn't stop there. With Cosmos 2.5, the story takes this fascinating strategic turn. The obvious move would have been to just make Cosmos 2 bigger and better, right? Well, Microsoft pivoted. Instead of continuing down the path of a generalist that understands everything, they went in the opposite direction and built a highly focused specialist. Its goal wasn't general vision anymore. It was to solve a completely different, high-value problem, making the AI literate. And this really lays out that shift perfectly. Cosmos 2 was about general perception, understanding snowman, fires, that sort of thing. Cosmos 2.5 pretty much abandons all of that to become an expert at one thing: reading text-heavy images like documents, forms, and charts, and really understanding their spatial layout. They call it a multimodal literate model, which is a pretty great name. This is way beyond basic OCR. It uses what's called spatially aware OCR to understand the structure of a document, the headers, tables, columns, and then it spits it all out as clean, structured Markdown. It's designed to turn visual chaos into organized, usable data. But here's the part that I think any engineer watching this is really going to appreciate. It's not just about the clever architecture, it's the practicality. This pivot towards specialization came with a huge advantage in efficiency. We are not talking about a massive data center scale model here. At just 1.6 billion parameters, community reports show that you can get Cosmos 2.5 running within 12 gigabytes of VRAM. That's a huge deal. It makes it an incredibly efficient, specialized tool that you can actually use without needing a supercomputer. However, there's always a catch, isn't there? That efficiency comes with a trade-off. As this user on Reddit points out, the model has some very specific and tricky dependencies. It needs particular library versions, specific NVIDIA hardware, making it notoriously difficult to get up and running locally. It's a powerful tool, but a temperamental one. So the whole Cosmos saga presents a really compelling argument. Instead of just chasing bigger and bigger parameter counts, maybe building smaller, smarter, and more focused models is the better way to solve specific, high-value problems with way more efficiency. It's a strategy of precision over brute force power. And that leaves us with a final, provocative thought. As we build the future of AI, is it going to be dominated by a few massive, monolithic giants that do everything? Or will it look more like a federated ecosystem of diverse, efficient specialists, each mastering its own domain? The Cosmos strategy really suggests that second option might just be the smarter path forward.